Shreya, welcome to the Mad Podcast.
Yeah, thank you. Thank you for inviting me. Really excited to be here.
So we are going to talk about the all-important topic of safety for the deployment of generative AI in production, which feels like a particularly timely conversation as people are starting to think about how you actually deploy those systems for mission-critical applications in production at scale and all of the things. So you are the co-founder and CEO of Guardrails AI, a startup that aims to provide, as the name conveniently indicates, guardrails around large language models. And I'd love to start maybe with that aha moment, for lack of a better term, when you realized you wanted to build this, particularly as it relates to your background. I think I read somewhere that you had spent time in the world of autonomous vehicle. What was that? Was that the trigger? What led you to start the company?
Yeah, I think it's I'm happy to dive deeper into that. So my background did play a key part in thinking of guardrails and in thinking of, what practically it would end up looking like as these models and applications built on top of these models, enter our day-to-day software stack. So it really started around end of last year. I was like everybody in tech, I was very excited about, the coming of generative AI, and especially as it relates to removing a lot of the previous barriers with doing machine learning. So for the longest time, training the model, getting the data ready, etc., would always end up being like this key, blocker before which you could actually do and build machine learning models. And suddenly it seemed like, all of those blockers were removed, so which was very exciting. And as I was building my own applications, I was kind of looking out to see like, okay, what is still challenging in this world, right? Like what would the net new problems end up being? And very quickly I came up on the idea, like, yeah, you can build very exciting prototypes in under 10 minutes that allow you to chat with your data set. But, that ends up being very insufficient because it doesn't actually, to an end customer or to an end user, it doesn't give you value like consistently, repeatedly, etc. And so, it ends up being in this realm of like, yeah, it's an exciting toy. And it's very fascinating that you can get like so much leverage out of, very little technological investment. But in order to like build lasting products, you would need to have much more reliability, similar to like you would need to be able to hold applications built on top of Gen AI to the same standard that we hold like software engineering products, right? Which like we live our lives on them, and like we need to get like Gen AI based technology to that same level. So that problem seemed like the key missing problem, where like, yeah, it works, but does it work enough, and does it work reliably enough? So I think that was the problem. And in terms of solutions, it was, I'm obviously biased because I worked in self-driving, but the way of like building products on top of ML seem more similar to self-driving than you would initially, suspect, wherein it wasn't just, here's this great model, and the output of the model is the commodity by itself, which is what you had in like the previous generations of machine learning, where you had like maybe churn prediction or something, and you do like analytics on top of that churn prediction model. Like instead, now you had this model which was kind of this like component of like a subsystem that is drawing upon like some other predictive components and like some data, and you're chaining a bunch of these together, and so that ends up being like a much more complex system. And in that, like errors and reliability and just working with the non-determinism of machine learning ends up being way more important. So this setup was very similar to self-driving, which is, you kind of like take this very vast problem of self-driving, break it up into chunks, and, apply machine learning very strategically and combine it with like other systems for verification, etc. And I wanted to kind of, build a framework that allows you to do something similar for all of the amazing like LLM applications that we're seeing. So that was kind of some of the motivation. I think it's been pretty, the initial analogy, like I thought it made a lot of sense, but it was definitely inspired. But it's been great to see that as the stack has started to like mature a little bit, as people are really thinking about like how do we put these things into production, the trajectory of issues and concerns that people are running into are similar to, like the path is similar to what it was in self-driving, which is, how do I get like this, runtime safety? How do I get like runtime constraints, etc.? How do I make it work with, how do I make this really flexible technology work with what I know to be true of the world? And making that work, I think like is that analogy ends up being like pretty powerful. So that was, those two things of like my own experience with self-driving, as well as, like building out these applications and figuring out where the gaps are. I think like that led to like this aha moment of like, okay, we need a framework like this if we were to build LLM safely. Yeah.
Great. So I'd love to spend a little bit of time on the problem itself. So as users, we all now very familiar with the concept of hallucination, just using ChatGPT or other systems and getting results of varying levels of quality, let's say. But what is the spectrum like? In what is the range of ways generative AI can go bad?
Yeah. So I think like hallucination is the top reason that everyone thinks of, and it definitely is a problem. Like I work with these systems, not just obviously from a from the creator of the open source and from the a founder of the company, but also like deeply as an engineer. And you do see the extent of the problem, even when the solution is like roughly right, it ends up being like actually it still is hallucinating like facts I never gave it. So that definitely is a problem. But outside of that, there's a lot of like implicit assumptions we make out of our existing workforce, and translating those assumptions into Gen AI based systems is unsolved to right now. So concretely, like what some of these risks would end up looking like is compliance, for example, is a large one where there's two failures with Gen AI. One is that our existing frameworks of making AI compliant within specific settings suddenly break down. So existing, for example, like model risk management frameworks don't really apply when you haven't built the model yourself. You didn't like curate the data that the model was trained on, and so you can't make any claims to that, right? I think the second one is that there's a lot of like other like I guess like guarantees that you expect for a system to be compliant that you then have to impose on generative AI. So my favorite example that I like using is if you're building a chatbot that works in financial services, then you want to make sure that the chatbot like never misleads the customers by giving it financial advice, right? So that, for example, is like one of the key risk areas. I think in general, other risk areas are around like brand risk. So if you're building a chatbot that has a commercial application, then making sure you're not saying anything that even if it's legal, like might end up being embarrassing to the brand, or might get you in the headlines the next day. That is something that's completely undesirable. So there's also this like need that people have to kind of poke and prod these systems to get them to fail, right? There's like people that kind of
I would never do that.
Yeah,
we've all tried.
Yeah, we've all tried, and it's very amusing to see like how you get there. There's entire like large subreddits dedicated to okay, how do you get these systems to say the most embarrassing thing? So I think like brand risk ends up being like another kind of key challenge. There's a few other ones around like privacy, security, etc. So people are very, very concerned about like PII, both PII going in, like leaving the organization system and going into these models, as well as these models accidentally like referring to some data that they were trained on, which has happened to me in the past, and I find it like very, very funny, and take screenshots but don't really do anything with those screenshots. So I think like that ends up being another concern. Yeah.
And there seems to have been a number of early attempts at mitigating the problem. I've spent like a lot of people in the space a good amount of time with our vector database friends, and then this like the whole concept of RAG that a lot of people have had a lot of hope for. Do you want to maybe talk about what that is and what's working about it, what's not yet working about it?
Yeah, absolutely. So RAG, for I think a lot of folks in your audience would know, but for folks that don't, RAG stands for Retrieval Augmented Generation. And it's essentially a method of building with large language models so that you're not directly questioning them. You're first sub-selecting context from your organization, from your application that's helpful, inputting that context into the prompt, and then, like asking the LLM to answer only using the context you provided. So as an example, let's say you have like some internal documents, let's say a standard operating procedure at your company, and then you want employees to be able to ask questions from that standard operating procedure. You would first figure out like what the most relevant subsections of that SOP are, and then input that as like append that SOP subsections to your prompt, and then ask a question from the LLM to like answer using the subsections you provide. So that's high level, what Retrieval Augmented Generation does. You retrieve the highlights and then you augment the prompt and generate. Yeah, just for summarization. So it is right now the primary way that most people are building with LLMs, especially I think like one of the most common interfaces that people end up building are chatbots. And the way to get like really performant chatbots that actually work for your context are with Retrieval Augmented Generation. There aren't really too many alternatives right now to do this outside of maybe fine-tuning your model. And even then, Retrieval Augmented Generation, like even with fine-tuning, it still might be helpful to do Retrieval Augmented Generation on top of that. That's
do you
also
just to jump into this? So there's RAG and there's fine tuning. Again, like very much to like you just did to make this interesting to a broad group of people. What does fine tuning actually mean? Everybody's sort of heard the term, but what does it actually mean?
Yeah, absolutely. So fine tuning used to be for the longest time, like before prompt engineering entered the scene, fine-tuning was the primary way to make machine learning models like work for you. And the idea was that typically in research, research labs or academia or other folks would end up designing like architectures, which are, ways of configuring like, deep learning neural networks together that like typically work really well for certain problems. And then you take that architecture as is, start with like a random initialization of that architecture, and then do a bunch of passes where you just input your data and then try to make that architecture work really, really well like for your data. So that was like more traditional. That was what training a deep learning model meant. I think then we ended up like in the trajectory of building these models, ended up getting to a point where the model sizes ended up just being so large and so massive, and the data that you'd need to actually get meaningful signal from those large architectures would end up being small, right? So your organization data would be much smaller than the size of the internet, for example. So then, we ended up in the space where we started doing like a lot of pre-training. So you take these architectures, pre-train it on very, very large generic data sets. And then once they're pre-trained, you'd essentially like take the small amount of like custom organization data that you have, and then, just like run a few passes that, with like very low learning rates that allow you to, just kind of sharpen the models like to your specific data. So this kind of like double paradigm of like pre-trained models followed by fine tuning that you do yourself ended up, kind of emerging as these model sizes like grew pretty substantially. So the key differences are fine tuning is so RAG, for example, is a runtime thing. So at runtime, you're figuring out what the most relevant context is. At runtime, you're injecting it into the prompt, etc. Whereas fine tuning is, like it's an offline process. So before you're able to like launch and release your application or your model, you would typically, spend like some time, figuring out what the right data that you want to fine tune is, and then training your model on that data, and doing a bunch of experiments to make sure that you are able to get like good model performance, etc. So that the level of investments ends up being like pretty different. Yeah.
Great, thank you very much for that. So if I'm an enterprise and I really want to deploy my own internal chatbot, let's say, and I have resources, of engineers, and I do that kind of like belt and suspender approach of doing both RAG and fine tuning. What does that mean in terms of hallucination? Are there benchmarks? Does that mean I'm at like 5% of hallucination or 15%, or like how do people measure the severity of the problem?
Yeah, I think it's a great question. I think you're kind of hitting the nail on like what the big like challenge in the space is right now, where evaluation is this big open problem, and we're at that point where we're already beyond where traditional academic metrics were, and so it's kind of like the Wild West a little bit out here. In terms of like organizations that are building, doing this like two-step approach of first fine-tuning a model and then doing RAG on top of that, first, props to them. I think it's definitely like, especially for fine-tuning, a big challenge ends up being, just getting the data set right. So for the last decade or so, we've heard that, data is oil, and data-centric machine learning, and, just getting that data set ready and together ends up being, a substantial investment. Obviously, that investment often results in that lift in model performance, and it allows you to work with, much smaller models that work better for your data, that often have like much lower latencies. But that in order to get those results, you typically need to make that initial investment. I think like where it's hard to quantify, like it's hard to give a blanket quantification of how much hallucination decreases by fine-tuning, because it depends on the type of task that you're doing fine-tuning on. So to make it more concrete, like there's different types of hallucinations, and depending on if your task is very, very structured versus very unstructured, and I'll get into that in a second, you might end up seeing like different lifts with fine-tuning. So this is anecdotal, but like some behaviors I've seen in my work is that if you have a very structured task that involves like either generating code in a specific language, or generating like a specific like structured data set, like a specific structured output like a JSON or a CSV or something, that with fine-tuning ends up being pretty effective. If you have an unstructured task where you essentially still want to do like question answering, but only on your data, that typically requires a much bigger data set, and often it's sometimes like harder to get that data curated as well, right? So depending on both the amount of data that you have for fine-tuning and the type of the task, whether it's like structured generation versus unstructured text, you might end up seeing different lifts. So you might still like, it's very possible and likely that you're still going to run into hallucinations even with fine-tuning. It's just going to understand like your task domain a little bit better. So at the end of the day, these models are, I mean, this is, I don't personally think this is a hot take, but for some reason this ends up being a spicy take, which is that, at the end of the day, these models are like next token predictors, which is, like they kind of look at like what they've predicted until now, and then, figure out like what the next token thereon is. And from that, like even with fine-tuning, that fundamental behavior remains the same, right? So the hallucinations happen because of this behavior, and fine-tuning kind of doesn't change that. This is kind of like a non-technical example I like using to kind of give an example of why this hallucination happens. Somebody I know was asking one of these AI models for kid-friendly activities or family-friendly activities in some city that they were visiting. And as this model was generating a list of outputs, it essentially, one of the outputs it shared was, okay, go to the zoo, go to the X city zoo with your family, and it's a good event. And then when they actually looked it up, that city never actually had that zoo. But because
But it could have.
Yeah, I think the city's lagging, the AI model. Like once the AI model has agreed, there must be a zoo. The city planning should get on that. Yeah, but it's so conditioned to think about like, okay, kid friendly activities, must include like a trip to the zoo. It doesn't, there's fine-tuning won't make that go away, right? Like fine-tuning won't make it go away that, okay, a zoo doesn't actually exist. So hallucinations aren't removed by fine-tuning, just as same reason that they aren't with RAG. Like with RAG, you end up getting like more context, and it's at runtime, so it ends up being a little bit more concrete, but it doesn't completely eliminate fine-tuning. I don't want to, yeah, I always feel a little bit nervous sharing like numbers of like 5% or not, because it's so context dependent. But like in my work, and I'm keeping this very vague because it's so different contexts, different applications are going to see different numbers, around like 30% or so, hallucinations like with RAG for a specific application. Yeah.
Yeah. And I assume the answer is probably no. Actually, I don't know. Maybe I'm wrong. But like given the above, if I'm an enterprise and I'm thinking whether I want to, work with GPT-4, which ever other proprietary sort of API kind of system, versus grabbing something of Hugging Face, open source, and just doing my own work or Llama 2 or whichever. Is there are all these models created equal in terms of hallucination, or is it like open source that can heavily customize, fine tune to my own needs is less likely to hallucinate? Is there a difference, or it depends on what you do with them?
So always depends on what you do with them, but right now the models aren't equal. I think OpenAI is definitely leading the charge in terms of, how effective, I guess just how flexible and generalizable the models are. But like other players, including open source, are quickly catching up. Let's see. I think there's, I'm thinking of like a benchmark called Legal Bench. Definitely recommend like everybody goes and check it out. Legal Bench was a benchmark that was released on a myriad of legal tasks, like, any task that, could be augmented or automated by AI in the legal domain. There's like some benchmark for that in this like Legal Bench, set. And in that, they essentially like evaluated a bunch of models, including open source. And then some of, you would typically see that like OpenAI based models tend to do very well on these tasks like they haven't seen before that are, newly created benchmarks. So I think OpenAI and specifically GPT-4 is pretty powerful and potent in that, in terms of its flexibility. In terms of open source models, there's this one study that came out recently. It was a blog actually published by the AnyScale team. Would also definitely recommend like folks go out and check that out. It was essentially a blog that looked at like summarization, and it, if I'm remembering correctly, it was hallucinations in summarizations and evaluating hallucinations in summarization while using GPT-4, which once again is the leading model out there, versus Llama 2 fine-tuned on some data set. And they ended up finding that like after fine-tuning Llama 2, the cost of running Llama 2 was much cheaper, and the performance was comparable with GPT 3.5, if I remember correctly. Again, I'm kind of getting this off the top of my head, so please forgive any inconsistencies.
This is great. Well, we'll link it in the show notes. But that's great.
Yeah, awesome. Yeah. So the interesting takeaway there was like straight out of the bat, if you just use Llama 2 directly, I don't think you could get like comparable performance, with GPT 3.5 or 4 today. But like with fine tuning, if you make that investment in curating your data set, in running that fine tuning job, and then serving it, then you're able to like on some of these tasks have these comparable performance. So I think that's where the strength lies, which is, if you're able to make that investment, then the technology ends up being like cheaper to run long term, and you end up kind of having more control over it. So that's how I would kind of like generally think about the differences. Yeah.
Okay, great. All right, so jumping into guardrails more specifically. So tell us about the general approach, and then after that, I'd love to actually jump under the hood and go into, you have actually concepts of guard and concepts of rails. I'd love to talk about this, but let's start with a general idea of what it is that you're building.
Yeah. Absolutely. So I think like the core insight that we had was that the models are insufficient by themselves, right? The models are great and really performant, and you can fine tune them and do a bunch of other things. But at the end of the day, what you really need is that the final like outcome that you're getting from the model like fits within the constraints of your systems, right? And those constraints might be accuracy or hallucination, or they might be like all of these other failure modes that we talked about, early on. So the key insight was like, yes, you can use whatever model you want, but then at the end of the day, you'd want to make sure that all of these like functional risks or harms that you care about, which is that there shouldn't be any hallucination. If I'm sharing some information to my end customer, I shouldn't ever be misrepresenting what I have or what I'm building to the customer, or I shouldn't be saying or my chatbot shouldn't be saying anything that's embarrassing to my company, right? These are like all of the areas, and you can add this to the prompt, but at the end of the day, you'd want to like have independent systems that check to see if any of those things are violated, and make sure that if they are, then, you know, you have like a very like flexible set of policies to mitigate and you know, just kind of stop that harm from occurring, right? So that was kind of the general idea of guardrails, where it works on a layer which, you know, surrounds the core LLM, and therefore allows you to, you know, like have much safer guarantees on top of, you know, the outputs that you're getting from the LLMs. And B is that, you know, it basically kind of like takes what is at the end of the day very flexible general purpose models, and make sure that whatever custom criteria, custom rules that you have, either from your organization or the domain that you're working in, you're able to take those rules and, you know, implement them and execute them in code, right? Which is you're taking a general model of the internet and making sure that it doesn't violate any policies that are internal to your organization, perhaps. So that was kind of the general idea behind guardrails, which is that you would need this independent validation and verification layer to make sure that you can actually use these models into production. So that was
do it at runtime.
Exactly, and do it at runtime. I think the runtime part is critical because, like, once again, no amount of offline evaluation, you know, like gives you that confidence that you need for shipping a lot of these things like into production. Yeah.
So how does that work?
Yeah, great question. So I think how we what the framework offers is like a few different set of tools to kind of make this problem, you know, tractable. So the first is the concept of runtime guards. What runtime guards do are they kind of surround your AI model and make sure that, you know, any of these functional concerns that you have are verified. So a runtime guard is typically created by combining a few different like validators together, and those validators typically check for, you know, like each constraint. So
what's a validator?
Yeah, so a validator kind of like is an independent check that, you know, like analyzes your output and scores it for one particular risk area. So any one specific risk turns into one specific validator. So for example, hallucination. You might have, you know, this one risk of hallucination, and making sure that any outputs that's generated is, you know, true given the source that you gave it. So what the hallucination validator will do, we call it provenance. So what the provenance validator does is it makes sure that, you know, there's no hallucination in the output that you're generating, right? There might be one more validator that is around, let's say, not mentioning any peer institutions. So if you're a company, you don't want somebody to ask you a question about like, okay, who's the best like I don't know, who's the best like tennis shoe company, and, you know, you're Nike and somebody else like says Asics or something, right? So that's just embarrassing. So there might be some reference of not making a reference to your peer institution, and so that would be one specific validator. Another validator might end up being, you know, just a very, very simple regex rule. So making sure that you're only allowed to answer in outputs that match like a specific pattern, right? So if you want to say, if you're extracting some information about an interest rate, you always know that an interest rate kind of looks something like this. And so you want to make sure that, you know, you're extracting information that fits that criteria. So all of these end up being, you know, very independent checks that check for you know, accuracy or performance or private information or hallucinations or, you know, compliance constraints. And there, you know, a whole catalog of validators that we have in Guardrails. And you can like take them, mix and match them, configure them, and combine them together into a guard that runs at runtime and makes sure that, you know, you're not like all of those criteria that you specifically want to check for, none of those criteria is validated, essentially.
Yep. And so double clicking on the provenance one. So how does that work? Like you go search into the source of truth and you match the answer against the whatever comes out of it?
Yeah. So Provenance is really exciting. We've done a bunch of work on Provenance, which is available in the open source. So Provenance, how it works is that any sentence or any utterance from the LLM should have some provenance that establishes, okay, this is the source where the sentence or utterance came from, right? So it's most effective in RAG, or Retrieval Augmented Generation systems, where you give the LLM some context and you want to make sure any output is coming only from the context and not from the general like world knowledge that the LLM was trained on, right? And this actually ends up being like a pretty even in practice. So for example, it ends up being a pretty like tactical problem. So you often see that even after you give it like some relevant context, if somebody asks a question, it'll like have some sentences from that context, but it also has like general definitions of what something means from the internet, and so it'll add those like sentences in there, which ends up being like misleading to your customers. So how the provenance validator mitigates this risk is it looks at like your output sentence by sentence, and then using a bunch of different like machine learning techniques establishes that from your source, with this level of confidence, your sentence came from this part of your standard operating procedure, or this section of your help center articles, or this section of your document, etc. So overall, that allows you to as a developer or as somebody building this application, it allows you to filter out any hallucinated sentences and only give the sentences that came from something that to be true and your company can support. And B, it also allows you to basically build interesting analytics on top of the threshold. So you can say that typically I tend to find that I only have like 80% confidence even in the sentences I know to be true, and so how can I like iterate on my prompt, etc., so that I generally end up increasing that confidence. Yeah.
Okay, and you mentioned machine learning techniques. It sounds like it's a little bit of a mix of like some validators maybe rules based and others machine learning based. Is that fair?
Yeah. There's actually even more. So rules-based, machine learning-based. We also sometimes, hook up, like when possible, when it makes sense for the validator, we hook up into some external systems. So for example, we've done a bunch of work in text to SQL, and we found that, our text to SQL validators were very, very competitive with like what the state of the art is using generic off-the-shelf models. And so how text to SQL works is we essentially create a sandbox of your database using your SQL configuration. And then any SQL code that is generated by the LLM is first run against that sandbox. Any errors are corrected. And then we allow the LLM to fix those errors, using the techniques available in Guardrails. So
Okay.
that, getting like a much bigger lift over directly using the LLMs. Yeah.
Okay. So some of it is a little bit machine learning to correct machine learning. So it's like how do you think about this? Because like the goal is to get to 100%, presumably like accuracy, but you have something that's not at 100%. You use something that's typically not 100% either to correct it. So how do you think about the getting to that 100%, or can one eventually get to 100%?
Yeah, I think it's a great question, honestly, and it's also like the key kind of limitation of working with machine learning, which is like 100% is almost never achievable. And so in practice, what you end up doing is like trying to, with an individual model, trying to improve performance as much as possible by training on better data, by using better techniques, and doing a bunch of other things. And B, and this is this is like one of the things that Guardrails really hooks into, is using this machine learning kind of like concept of ensembling models together. And what that typically, I think my favorite way of explaining what that does is that you can think of ensembling as stacking a bunch of different like sieves on top of each other, where each sieve has holes in like different areas, right? So the stack of different sieves ends up being so that your holes are all like non-overlapping, and so you end up getting something that is greater than the sum of its parts and ends up being like more watertight and more like correct. So ensembling kind of works in a different way, which is you have like your large large language models such as OpenAI or Anthropic or Cohere or, Llama 2. But that has like specific failure modes. You combine it with, these guardrails and validators that also under the hood use machine learning, but they have like maybe some other different failure modes. And when you run like this whole ensemble together, you end up getting something that is, much more performant and tends to like have much higher robustness compared to just using the model by itself. So I think in general this idea resonates a lot with this recent like blog and writing from the Hazy Research Lab at Stanford, which I'd also recommend people check out, which is LLMs and generative AI really help solve like the first mile problem in ML, right? But the last mile problem, which is like, how do you take this generic generalizable technology and make it work like specifically for your use cases and for your actual application? Like you need other more traditional ML tools to make sure that you have the guarantees and you have the reliability that you typically need. Yeah.
How does guardrails manifest? We talked about failure modes earlier, but sort of as a like generically across RAG and other things. Like how does that manifest if the chatbot, for example, mentions the name of ASICs in the shoe example? What happens? Like do I control this, or does it just say does it kill the answer? Like how does it fail? What's my sort of end user experience?
Yeah, I think that's a great question. We thought about this a bunch. So the open source supports a bunch of different policies on failures that allow you to configure your level of risk. So in the extreme, what we support is this re-asking strategy that Guardrails kind of supports really, really well, where it hooks into the LLM's ability to self-heal or correct their own outputs if you give them enough context, right? So how that works is that, let's say you have an LLM output and it fails the validator that says you can't talk about your competitor. And so what Guardrails would do, or Guardrails re-asking would do, is it would automatically construct a new prompt and only give it the information it needs to be able to correct its output. And then you send your prompt back to your LLM, get a new output, and more often than not, that output ends up being correct. So once again, it's not 100%, it doesn't work 100% of the times, but it does end up working like pretty substantially in a lot of outcomes. So that is like one of the strategies of how do you handle failures. But there's a bunch of other things available, including programmatic fixes when possible, right? So if there's any hallucinated text that is detected, you just filter out that specific text and don't throw out the rest of the answer. In some other cases, you can like alert a human and then bring a human to review that output and make sure that like only when a human okays it do you send that output forward. And there's a bunch of other like filters around like responding with like canned responses or falling on like other fallback systems, raising an exception, etc. So like all of those options are completely configurable, and you can set them like on a validator level. Yeah. So for example, like it might end up being that, if you have, if you're mentioning a competitor, that is dangerous enough where you'd much rather like make that extra trip to the LLM rather than, sending that response out. And so you can configure that policy just for the competitor check validator. A bunch of other things like, I don't know, always ending a chatbot response with like thank you or please, right? Maybe it's bad, but it's not as bad that you'd much rather like answer the question faster rather than make that extra trip. So you might, maybe like programmatically like inject that at the end of the sentence. And so for each validator, you can like configure what the policy needs to be. Yeah.
As all of this happens at runtime, how should one, or how do you all think about performance, latency? Does it have any impact?
Yeah. For I think that's there's no like there's basically no free lunch in terms of safety. So typically like running these validators like ends up incurring some additional cost. So there's both in terms of like latency as well as compute or making another call to the LLM, etc. So we generally think about it in two ways, which is like one is a lot of the validators are only useful when you have these like specific runtime constraints, right? And we've done a bunch of optimizations to make it like as fast as possible, including being able to like parallelize all of these validators so that, you know, you end up like only getting like the minimum runtime that you need. I think the second thing that we do is essentially configure a bunch of different options that allow you to trade off you know, cost, quality, performance, etc., so that you end up getting something that works within your constraints, right? So for example, for hallucinations, we essentially have like multiple implementations of those hallucination detectors, or like the provenance validators that allow you to say like, okay, if I want the really, really great performing outcome, I might need that extra cost and that extra time. But if I'm okay with, you know, like if I don't have as strict constraints around hallucinations, I can do with the really fast, but maybe not that good, you know, performance. So this is also very in line with machine learning. And in machine learning, you know, like the best models are typically like really large and end up having that extra latency. So I think we kind of get some of those similar principles into Guardrails as well. Yeah.
Great. So you're early in the journey of building the company, at the same time very active and shipping, and congratulations, by the way, like I saw you release the 0.20 version just a few days ago, so that's fantastic. What's the role of open source for this business? And the question behind the question is, you know, open source is a great way to build community and users and all those things. Like occasionally open source, or maybe what it was originally was like you had a bunch of people that were helping to build parts of this. So is there like a very large number of validators, and part of the idea is that the community is going to build some of those validators? Like how do you think about community, not just from a go-to-market perspective, but from a product development perspective?
Yeah, I think that's a great question. I think the community is definitely contributing like a number of these validators. I think I'm not sure when the episode will go out, but like this morning, you know, we had like a contribution for like a regex check. So making sure any output that you have like matches a specific pattern that you predefine, which was, you know, contributed by the community, etc. So people, it's very interesting because like the applications are so wide and varied, and then based on that, people end up, you know, making like specific types of contributions. So I think we're definitely focused on that. I also do think that like what the open source really ends up doing as you know, a framework is taking down this very abstract problem of what it means to do safe AI development, right? Like it's a very abstract problem. It's almost an academic problem to some degree. And it takes that and it breaks that down into, you know, an engineering problem really, right? Like, okay, if these are the risk areas that you care about, this is exactly how you mitigate and safeguard against those risk areas, right? So it ends up like having like a much more like these safety measures that are grounded in code rather than just in policy. And so that I feel like is a big value of the open source. And that's also, you know, why a lot of people like use the open source, in addition to the fact that, you know, it ends up providing them like much higher performance and safety and everything. So I think like that allows us to kind of, you know, it allows us to kind of shape how safe AI development is done in industry, right? So it allows us to basically kind of build these systems that are, you know, much more reliable using techniques or frameworks. I guess using the architecture stack that Guardrails kind of lays out. So that ends up being like a lot of the value. Yeah.
How big is safe AI as an industry? And you know, maybe it'd be interesting for people here that want to learn, if you could mention like who else you think is doing interesting work. And I'm not necessarily asking to mention competitors or anything, but I know researchers, like papers, or people doing great work in big tech, but in that sort of AI safety space.
Mm-hmm. Yeah, I think like safe and responsible AI has always existed as an industry, but is, you know, obviously with the explosion of generative AI that we're seeing and the proliferation of these applications like becoming much more relevant. So there's a lot of like interesting work from a bunch of different organizations. I do think the OGs in the space were like Microsoft's, you know, responsible AI team. I think coincidentally, they're also called the Rail team. No affiliation between like our Rails and like Microsoft Rails, but I think there's some of the teams that, pioneered a lot of the really amazing work that Microsoft is doing, leading the charge in generative AI and making sure that all of those products are kind of, safe and responsibly developed. So I think like that is pretty exciting to me. I think in research, there's a lot of like exciting work, both from the security side as well as from the AI side. I definitely recommend, Percy Liang at Stanford. So his team, for example, does a bunch of work in like verifiability, which is pretty exciting. There's also, so I think from the security side, there's also some really exciting work by, this professor Leon Derchinsky. I'm probably going to mess up the name pronunciation, but he's doing really fantastic work on, from the security side about like how to safeguard LLMs. He's a professor at University of Washington. So I think like those are some of the academic side, which are pretty promising and exciting to me. Yeah.
Okay, very cool. Thank you so much for sharing this. So maybe to close, taking a step back, and still, as part of a general desire to make this educational for folks, you're navigating in all the right crowds. As I was prepping for this, so you're partnering with LangChain, you were doing like a Hugging Face meetup, you're partnering with Weights and Biases. We actually had Lucas on this podcast a few weeks ago. Who do you think does interesting work in generative AI these days? Maybe beyond those names, which are sort of some of the obvious ones, but whether those are friends or colleagues or people that you sort of follow from afar, that people should look up or research, or like anything that comes to mind. Big company, small company.
Yeah, I think that's a fantastic question. I think we're also at a point in time where it honestly feels like a fire hose, and it's like you're keeping up with this fire hose and
Yes.
just getting swamped every day. So let's see. I think on the company side, I do think like Llama Index is really really cool. I think like I said, RAG is the way to build these models today, and like Llama Index is again taking a very like grounded approach to doing that. So I think they're a pretty cool company.
Yes, and we had Jerry on this podcast also a few weeks ago. If people are interested, you can go back a few episodes and check out our great conversation with Jerry, the founder of Llama Index.
Yeah, I think Jerry's fantastic. Obviously, I think you mentioned like a lot of other fantastic people. I think like LangChain is obviously leading the charge. I do think like Langsmith is a great, they're making a great push around LangChain, and I think that's awesome. Weights and Biases, I've long been a fan of Weights and Biases, and I think they know that as well. I've been using it for many years, in addition to my ML work like over all these past years. I think specifically in generative AI, I do think that like all of the foundation model companies are still, they're still like pretty much like it's very hard to get away from the fantastic work that they're doing. So OpenAI, obviously, like I said, like their models are kind of like really competitive, but Anthropic with their constitutional AI, I think that was a really fantastic approach to thinking about AI safety in a very principled manner. And I think Cohere, I think Cohere is doing a really fantastic job. We're taking a much more kind of like enterprise focused approach to thinking about generative AI. So they recently had this model release called Coral, I think, which is a pretty fantastic implementation. I think their re-ranking model is something that I know a bunch of people I've spoken with like use in their actual systems. I think some other companies that are really exciting to me some other academic work that is really exciting to me are how do you take what is now the limitation of generative AI and what's going to come next on the horizon, right? So on that, a lot of the work, once again, from the Hazy Research Lab and like TreeDAO on, like a lot of like flash attention, etc., which allows you to train models with like much longer context and, allow you to iterate on like the inference time speeds of these models. I think that's pretty awesome. Also Albert Gu, at CMU, and his work on like S4 models and state space models is I think like really promising. So we definitely look at like what's kind of coming next on the horizon in terms of, like what's next beyond transformers, essentially. Yeah.
Okay, fantastic. Where can people find you online?
Twitter is I'm fairly active on Twitter. You can follow my personal account, which is Shreya R, or the Guardrails account. I think we both talk about the exact same thing, so so either works. I'm on LinkedIn with my name Shreya Rajpal, and then also check out the Guardrails website and the GitHub. So guardrailsai.com, or the GitHub at if you just search for Guardrails AI, it'll be the top result. Yeah.
Very cool. And presumably you're recruiting. Who are you looking for?
Yeah, we're actively recruiting right now. If there are amazing machine learning engineers, please reach out to us at contact@guardrailsai.com. We're also looking for folks on the open source. People that have experience like working with open source communities. So same email address, contact@guardrailsai.com.
Great. And you can add a /Mad Podcast so we get a 25% placement fee.
Yeah, absolutely. Yeah.
All right. This has been a wonderful conversation, Shreya. Really appreciate it. And this is super interesting. I'm very excited to see how you all do in the next few years, because it sounds like you're focusing on a super important problem with a really interesting approach. So I'm excited for the next steps. Thank you so much for coming on the Mad Podcast and telling us all about it. Thank you.
Yeah, thank you so much. Thanks again for inviting me, and really enjoyed our conversation. Yeah.
Bye.
Yeah. Bye.